Welcome to Pitch Lab. My name is Dorothea Wendt and I'm a senior researcher at Eriksholm. Let me show you what we do in pitch. What we typically do here is that we measure our patients' eye movements and pupil size, because the pupil size actually tells us a lot about how people spend their cognitive resources when communicating. So what we do is we seat people in front of the eye tracker, and the eye tracker is simply recording the pupil size of our test subjects, which we call pupillometry. The typical task our test subjects have to perform inside here is to listen to speech and noise and repeat back what they've heard. While they do that, we measure their pupil size as an indicator of the listening effort they have spent. And this is because the pupil starts to dilate as soon as they listen to speech. And we measure this dilation of the pupil. The advantage of pupillometry is that it provides an objective way of assessing our test subjects' listening effort, and we are able to run it with our traditional speech and noise test at the same time. In our typical test scenarios, the test subject is sitting inside the booth while we are presenting speech and noise through the loudspeakers like this.
Flowers grow in the garden.
From here we control the actual experiment. We can track the test subject's eyes, as you can see here, and we can present the sound to our test subjects. Typically, a higher pupil dilation would indicate higher listening effort. And you may wonder how that is possible. Well, this is due to our autonomic nervous system that acts as a stress regulator of our body. In a situation that we perceive as stressful, for example, communication in a noisy environment, the autonomic nervous system's activity would increase, which has as a consequence the dilation, a higher dilation of the pupil. So in this video you can see a pupil dilation that was recorded of one of our test subjects, and what you can see here is that the pupil dilates as soon as person listening to speech and noise, and the higher the pupil dilation, the more listening effort. What we have learned here is that the more acoustic challenging the listening situation is, the more listening effort people have to spend. And that is reflected in a dilate pupil size. We've also learned that people with hearing loss would typically have to spend more effort in order to reach similar performance or speech intelligibility levels compared to their normal hearing peers. We have also learned that hearing devices and their signal processing can help to reduce the listening effort, even in situations where speech intelligibility is high, reflecting everyday communication scenarios. Thank you for visiting Pitch.